Okay, so this lesson is about the integral of a rate equals net change. And if there is one of the lessons, one of our lessons would be in like the top 5, this would absolutely be it. All right, so the integral of a rate equals net change is something that we are going to talk about all the time. And one of the reasons it's important is because it comes from the fundamental theorem of calculus. The fundamental theorem of calculus says the integral from a to b of f of x dx can be evaluated by taking the antiderivative, capital F, plugging in b and a and subtracting. Well, we can extend that idea and say that would mean that the integral from a to b of f prime of x dx equals regular f of b minus f of a. Okay, because it's still an antiderivative, and I plug in the bounds and subtract. This, though, is basically a way of saying that the integral of f prime equals delta f. The integral of f prime equals delta f because these are two y values. So this is delta f, and this is the integral of the derivative. Hence, my generic heading, the integral of a rate, derivatives are rates of change, the integral of a rate will give you net change. Okay, so we're going to start this by looking at rectilinear motion and then move into other things. I will try to talk fast so I can get this video in a reasonable amount of time. But if you're watching this for the first time, it'll probably be over 20 minutes. But if you're watching only part of it at a time, it should be less than that. So from then, we'll just kind of keep moving here. All right, so we're going to talk about displacement here and talk about position, acceleration, and velocity. So I want to talk first about the difference between displacement and total distance traveled. So if I said we are going to take 2 steps forward and 1 step back, what does that mean in terms of total distance traveled? Well, 2 steps forward and 1 step back mean I took 3 steps. However, my displacement is I've only moved 1 step forward. Okay, notice there are 2 different values in that instance. Total distance and displacement are different things. Displacement can be found by integrating velocity. Okay, the integral of velocity, the net area under the velocity curve, gives you your net change in position. So when we go to do our displacement, I'm sorry, 3 people just wandered into my room, giggled, snorted, and then left. So when we do our displacement here, the displacement is going to get me the net change in position. Total distance traveled tells me, like if I were driving a car, how much my odometer would change by. Total distance traveled is the integral of the absolute value of velocity. So instead of giving me the net area between the velocity curve and the x-axis, it's going to give me all the area between the velocity curve and the x-axis, okay? You need to memorize these. So when I say displacement, you need to know integral of v of t. When I say total distance traveled, you need to know I mean the integral of the absolute value of v. Okay, so moving on down here. Suppose the velocity of a particle is given by this v of t from the interval from 0 to 2. When is the particle moving left, right, and stopped? Well, we talked about this before. I'm moving left, right, and stopped. That's dependent upon the sign of velocity. So I'm going to set my velocity equal to 0. Let's see, I'm going to divide by 6. That's going to be t minus 2, t minus 1. So at t equals 1 and 2, my velocity equals 0. When velocity equals 0, that means I'm stopped instantaneously. So these are the 2 values where I'm stopped. These are also the values that make up my endpoints for my intervals. So if I'm looking on the domain from 0 to 2, I have one interval that's going to go from 0 to 1, another interval that's going to go from 1 to 2. Inside these intervals, I need to know about the sign of velocity. If velocity is positive, I'm moving right. If velocity is negative, I'm moving left. So if I find v of 0.5, let's see, if I look over here at the factored form, if I put 0.5 in for t, I've got a negative times a negative, which is a positive. We are moving right on this interval. If I find v of 1.5, and I look again at the factored form, I have a negative times a positive, which is negative, so I'm moving left right here. Okie doke. Find the particle's displacement for the time interval without using your calculator. Okay, so we said displacement is the integral of velocity. So I want the integral from 0 to 2 of 6t squared minus 18t plus 12 dt. So I have to evaluate an integral. I'm going to take the antiderivative, plug in the bounds, and subtract. So I'm going to add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and slap a t on there from 0 to 2, and that's going to be, let's see, 2 times 2 cubed minus 9 times 2 squared plus 12 times 2 minus a whole boatload of zeros when I plug in 0. So let's see, this is 16 minus 36, that's negative 20, plus 24, that's going to give me positive 4. My displacement is positive 4. Okay, find the particle's total distance traveled by setting up one integral with my calculator. Okay, total distance traveled is the integral of the absolute value of velocity. Now notice the absolute value is inside the integral, not outside. That would give you a different answer. So the integral inside gets an absolute value on it. And you will see right there that I've already typed it in, so you don't have to watch me fumble through that. And I get 6. Now, let's say I wasn't going to do it in the calculator, okay? If I wasn't going to do this in the calculator and you want to integrate an absolute value, what you have to do first is graph the function that you've absolute valued. I just decided to make that a verb. V of t is the function I've absolute valued. I know it's a parabola with roots of 1 and 2, and I'm integrating it from 0 to 2. If I'm integrating the absolute value, that means I want to consider both of these positive areas. Well, the first one from 0 to 1 is already going to be positive. The second one from 1 to 2 is going to be negative. So what I would do is just subtract. So if you didn't have a calculator, the only way to integrate absolute value is to split it up into positive and negative sections and negate the sections that would have a negative integral. Okie doke. All right, find the particle's average velocity on 0 to 2 using the average value formula. Average value has a formula. It's 1 over b minus a, the integral from a to b of what I'm averaging, and I'm averaging velocity, so that's going to be 6t squared minus 18t plus 12. And I've already done this. I did it up here, if you remember, and it got me 4. So this is going to be 1/2 times 4, which is 2. There's my average velocity. Now, how else can I have done this? Average velocity is exactly displacement divided by your change in time. Displacement over time is average velocity. Think of it this way. How fast did you go on average? Well, to figure it out, you'd figure out how far you went and divide it by how long it took you to do it. And that's what we're doing. And then last but not least, it says find x of t if it's known that x of 1 is 0. X of t, this is going to be my position function. So if my velocity is 6t squared minus 18t plus 12, then my position function is the antiderivative. Add 1 to the power, divide by the new power, 9t squared, 12t plus c. And x of 1 is 0. So let's see, that means 0 equals 2 minus 9 plus 12 plus c. And I'm getting, let's see, that's going to be 2 minus 9 is negative 7. Negative 7 plus 12 is 5. 5 plus c is 0, so c must have been negative 5, making x of t 2t cubed minus 9t squared plus 12t minus 5. Yay. Okay, end of a page. I got to tell a stupid joke. Here's the stupid joke. Ready? What happens if... No, I said it wrong. I've already ruined the joke. Oh my gosh, it's so stupid I can't remember it the right way. Oh no, I know what it was. If you lose your hearing, is it irreplaceable? I know it's terrible. Totally terrible. I'm going with it though. Okay, next. This next page is all about the fact that this stuff doesn't just have to do with velocity and position and acceleration and blah, 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 blah. It can be doing with anything having to deal with a rate. So, on example 3 here, it says the rate at which Mrs. Vibber grades papers at home is measured by G of T equals that thing, papers per hour on the time interval from 8 to 12, because I can't grade your papers until my kids are asleep, which is usually somewhere between 8 and 9 o'clock, and then I drink some coffee and grade papers, which is why sometimes I do things wrong, because I'm tired. So, here's the rate at which I grade papers. Cool. What kind of questions am I asking here? Is the rate at which I grade papers increasing or decreasing? Well, I know if something's increasing or decreasing based on the sign of its derivative. So if I want the sign of the derivative here, I just want to know what's the sign of g prime of 9. I told you to use your calculator, so I am going to do that. So I'm going to pull up the calculator. I'm going to go into y equals, and I'm going to type in this g of t function right here. So I put that in y equals, and the calculator can get me the derivative. So I'm going to go math 8 for n deriv. I want to take the derivative with respect to x of what's in y1. Again, alpha trace brings that guy up. And I want to evaluate the derivative at 9. Da-da-da, negative 10.922. Now, if my g prime is negative, that means the rate at which I'm grading is decreasing. Should write g. G of t is decreasing, or g of x. Oh, look at that. This is supposed to be a t. Sorry about that. G of t is decreasing because g prime of 9 is negative. Cool. All right, I'm at 12 minutes. Wow, I talked a lot faster than I thought I did. Evaluate the integral from 8 to 12 for g of t. Again, I have a calculator. So 8 to 12, g of t dt. I'm going to pull my calculator up again, and I'm going to go math 9, 8 to 12, alpha trace, y1, dx, 85.797. Give units for my answer. Okay, so my units would be, when I integrate, I'm technically doing area. G of t is measured in papers per hour, and time is measured in hours, so this is really just papers. Mrs. Vibber, talking about myself in the third person, has graded 85.797 papers on the interval from 8 to 12. Okay. Let's see. If we used LRAM and 4 rectangles to approximate this, would LRAM give an over and underestimate? Okay, there was something that I said before about LRAM and MRAM and RRAM and trapezoids about over and underestimates. Oh yeah, it had to do with the graph, right? So I'm going to go back here and I'm going to graph it. Trust me, it looks like that. I've already fixed my window. If I look at that graph and I think about LRAM, look, I can do this, you can't. If I take this graph and I think about LRAM, LRAM would look like this, right? LRAM's going to be an overestimate. Why? Well, the y, I have 2 options. Either it's y because it's concave up, or y because it's decreasing. It's y because it's decreasing. LRAM is an overestimate because g of t is decreasing on the interval from 8 to 12. Okay? Now, how do I delete this thing? That's a good question. Cut. Look at that, I did it. Woohoo! Okay, moving on. Let's see, what else have I got here? Use 4 trapezoids. Okay, so now I'm supposed to use trapezoids to estimate the integral from 8 to 12 of 1/4 g of t. Okay. Give units for my answer. Describe what it represents. Why would I have a fraction out in front of an integral? Average value. Who said that? Oh, it was me. It's average value. This 1/4 is the width of the interval. So describe what this answer represents. This is the average value of g of t on the interval from 8 to 12. Well, if this is the average value of g of t, it should have g of t's units. So this would be in papers per hour. Okay, so now I got to actually do these 4 darn trapezoids. Fine. So let's see. If I'm going to use 4 trapezoids, they're going to be equally spaced over a width of 4, so they all have widths of 1. Trapezoid is h over 2, b1 plus b2. So that's going to be g of 8, 2 g of 10s, 2 g of 11s. Let's see. 1, 2, 3. I forgot 9. 2 g of 9. Pretend I did that first. It's like somebody's missing. And a g of 12. Because remember, when you do trapezoids, you double the innards and you keep the outsides a single. Again, pretend the 9 came in front. I just apparently can't count. You know what's really odd to me? Numbers that aren't divisible by 2. Anyways, so moving on. I had to stick another bad joke in there, so I'm going to actually do this here on my home screen. So I have 0.5 alpha trace g of 8 plus 2. I'm going to pause because I know you guys are really bored watching me type here, so hang on. I'm going to pause and this will magically appear. Okay, I typed it in. You can kind of see it there. I got 88.585, which seems reasonable because the exact value was 85.797. So I have 88.5. What was it again? 5 something. 585. And that needs to get multiplied by a quarter. So let's see, I'm going to divide that guy by 4, 22.146. And this is papers per hour. So this is the average rate at which I grade papers. Is this an over and under approximation? Dear gosh, Mrs. Vibber, are you done with the over-unders yet? Well, this time I did trapezoids, and if you remember the graph, it looked like this. It was concave up, so my trapezoids would connect on top of the curve. So this is an overestimate because G is concave up. Mrs. Vibber, you should have given us more space. I know, I'm sorry. Okay, still going. What do I got next? My phone is dinging. Be quiet, phone. At 10 p.m., Mr. Vibber started helping Mrs. Vibber grade some multiple choice quizzes. He would never do that. We're just going to pretend he does. So he's going to grade some multiple choice. On the interval from 10 to 12, he can grade at the rate of V of t equals that. How many papers do Mr. and Mrs. Vibber grade together? Grade together by on, that's silly. How many papers do Mr. and Mrs. Vibber grade together on the interval from 8 to 12? Okay, well, do we know how many papers I graded already? Yeah, I graded 85.797 papers, so I already have mine. Then we're going to add the papers he grades, but he's only grading from 10 to 12. So then I'm going to take the integral from 10 to 12 of v of t dt and add it to my original. Easy peasy. So I'm going to pull up my calculator again, and I'm going to do math 9, the integral from 10 to 12 of 25 sine. Remember, you're in my class, so you should be in radians right now. Nope, nope, stop it. Oh my gosh, I'm sorry. My baloney has a first name. It's O-S-C-A-R. I'm singing songs. Plus 4. And wasn't there a plus 2? Plus 25. There we go. Blah. All right, so he's only got multiple choice. So he's grading a little bit faster than I am, and it was how many again? 70.806. And so if I add that to my 85.797, and remember I need my final answer to be correct to 3 decimal places, so I'm using some extra ones up here just in case there's a rounding issue. 156.603. Yay! Whew! Okay, I'm almost done. You gotta hang in here with me one more time. And a lot of you are starting this probably in the middle. So I'm at 20 minutes right now. Let's see how fast I can do this next one. The tide removes sand from Sandy Point Beach at a rate modeled by the function r given by that. Hey, what did the ocean say to the sand? Nothing, it just waved. A pumping station adds sand back to the beach at that rate. Okay, cool. R and S have units of cubic r yards per hour. And T is measured in hours from 0 to 12. Let's see. And at time t equals 0, the beach contains 2,000 cubic yards of sand. Okay. So, purple. How much sand will the tide remove from the beach during this 12-hour period? Okay. So if I want to know how much sand it's going to remove, I'm dealing with that guy right there. And the integral of a rate gives me the net change. So the integral of r of t from, what was it now? 0 to 12 will tell me how much sand is removed. So I'm going to put this into my calculator. So what I'm going to do is, because I know I'm going to use R and S repeatedly, I'm going to put one of them into R1 and one into R2, because then I have them and I don't have to worry about dealing with typing them in every single freaking time. So I shouldn't say that word, every single time. There we go. There's that one, and then this guy. Again, I'm just typing it in. La di da di da, ba da 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 da. Do do do. Do, 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 do. Okay, so there's R and S, and they're in Y1 and Y2. And so I want math 9 from 0 to 12 of alpha trace Y1 dx. 42.111. Cubic yards of sand. Write an expression for y of t, the total number of cubic yards of sand on the beach. Okay, so I have sand on the beach. I started with 2,000 cubic yards of sand. Then the beach is going to take away some of my sand, and it's going to take away sand at a rate of 3 plus 4 cosine 5 pi x over 24 dx. And then it's going to add sand. Is this still recording? I'm kind of nervous that it isn't. Is it recording? Yes, it's recording. Then it's going to add sand at a rate of, let's see, 12t over 3 plus 2t. But actually, I want to make those x's, and you'll know why in a second. Come on, write x's, pen. 3 plus 2x dx. And I am going to do this, let's see, from 0 to t. Does that make sense? So remember, if I integrate with a variable bound, that means I can change my time at will. And this might be even easier to write as a single integral. If you've got the time, you don't have to erase yours, you probably have space. I just wrote really big. This is really just the integral from 0 to x, 0 to t, of r of x minus, oh gosh, Mrs. Bibber, I don't feel like re-recording this, so I'm just going to apologize. There we go. Okay, so let me rewind. Okay, rewind. Y of t equals the 2,000 yards of sand I already had plus the integral of the sand I'm adding minus the integral of the sand I'm removing. Because the integral of the rate will give me the net change in sand. So 2,000 plus that will give me the total amount of sand on the beach. Then it says, find the rate at which the total amount of sand on the beach is changing at t equals 4. So I really want y prime of 4. Well, y prime would ditch the 2,000 and ditch the integral, and that's just going to be s of 4 minus r of 4. The difference in the rates is the overall rate at which sand is changing. So I'm going to go back in my calculator here and do s of 4 minus r of 4 and get 4.8277. From 0 to 12, at what time is the amount of sand on the beach at a minimum? Which means I'm dealing with absolute minimum. What is that minimum value? Justify your answers. Okay, my absolute minimum can occur at either end points or critical points. So it could happen at t equals 0, it could happen at t equals 12, or it could happen when the derivative of the amount of sand equals 0. Okay, so if I want to know when the derivative for the amount of sand equals 0, that's y prime of t. Y prime of t would just be s of t minus r of t. Right? Because if y prime is up here, y prime of t is s minus r. I want to know when this equals 0 or does not exist. Okay? In my calculator, I already have s and r graphed, so all I really need to know is where they cross on the interval from 0 to 12. So I'm going to go to my window. I'm going to change my x window from 0 to 12. And since I want to know where they cross, I'm going to think about their range for a second. Let's see, r would have a range from 7 to 1. So I really should just make my y window go from like 0 to 10. Here comes r. I said 7 to 1. I meant 7 to negative 1. Sorry. And there's s. And it crosses, holy cowabunga, it crosses 3 times. Okay, fine. So I am going to alpha, no, not alpha. Go away, alpha. No, seriously, stop. There we go. Second calc intersect. First curve, second curve. My first guess is like 2-ish. Thinking, 2.186. Okay, now, bear with me. I'm going to quit and store this as A, my first intersection. Then I'm going to go back and do the exact same thing and store the next one as B. My second guess is like closer to 8-ish. Oh, I was really close. 8.024. Again, I'm going to go back and store this as B. And I'm going to go back to the graph. Second calc intersect. First curve, second curve. My last one happens closer to 12, so I'm going to say 11. 11.071. And again, I'm going to store that. I know you guys are dying here. Just bear with me, bear with me. Okay, there's those 3. Now, these are all possible maximum values of sand on the beach. All of them. They are all possible minimum values for sand on the beach. We want the minimum, so what we have to do is find the amount of sand on the beach at t equals all of those values. And you're all thinking, Mrs. Bibber, I hate you so much. And I know. So we're going to find y of 0, y of 12, y of 2.186, y of 8.024, and y of 11.071. Y of 0, how much sand is on the beach in the beginning? It is 2,000 yards of sand. I already knew that. Okay, so there's 1. Y of 12, so I'm going to go into my calculator. I promise I'm going to do this as fast as I can, is going to be 2,000 plus the integral from 0 to 12 of y2 minus y1 dx. Okay? And I'm going to get a number. Come on, you can do it. Do, 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 do. Seriously. Come on. 2010.113. I'm going to go back. I'm going to do the exact same thing, but I'm going to hit second enter. And I'm going to change my 12 to an A. See, that wasn't so bad. 1992.414. Mrs. Bibber, shouldn't you round? Nope. The AP says I can round or truncate, so I truncated. So then I want to change that A to a B. Come on. Alpha B. Come on. You can do it. Come on, little calculator. 2012.680. Almost done. I'm almost done. You've come this far. Hang on for the end. So I gotta go back here. Oh, I went too far. Come back. See. Come on. Come on, little calculator. Come on. 2009.063. What was it again? 063? Yeah. Where is the absolute minimum? Right here. When does it happen? At 2.186. So there's T. There's the min. Dear heavens. Okay, so we're done. Done, 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 done. And the bad joke tonight is, how fast does a snail go when he doesn't have his shell? How fast does a snail go when he doesn't have his shell? I don't know how fast he goes, but I know he's pretty sluggish. Okay, I'm done. Seriously done. All right, thanks for hanging in there. Talk to you later.